Kia ora, iti iwi, I taone, koutua katoa. Greetings to you all. In today's talk, we're going to look at information related to archaeological sites of the New Zealand walls from 1840s to 1880s. Recent archaeological work in South Auckland renewed new interest to look at archival and LiDAR data, producing innovative ways to combine the two. Recent CRM work at Galloway's Readout and Ring's Redoubt motivated the use of these techniques to move towards a focus on geotemporal models for both research and heritage management practices. Myself, Ben Jones, and Simon Bickler will be talking about this today. As you can see here, it's kind of the structure of this talk. First, we dive into previous research and what we know about the fortifications on both sides of the conflict. Second, we discuss what stimulated this research, specifically trying to find a missing readout. Third, we dive into the old newspapers to give some historical context for the features being mapped. Then we move into the LiDAR methodology itself, some of the problems that we needed to iron out, and the template composite that we are moving towards accumulating in a 3D reconstruction. So we'll briefly outline some of the previous research and summarize what we know about these fortifications on both sides of the conflict. We describe our initial endeavor to find one of the missing sites that seems to have largely disappeared from the story. We want to show how new techniques might aid bringing these places back into light, and how the methodologies we develop can be used to develop a more generalized landscape approach to interpreting these sites. To do this, first, we demonstrate the use of data in old newspapers to give some historical perspective, what people were writing, and how the war was viewed from a Pakeha perspective. Second, we dive into the method we used for the LiDAR to give context to these sites and the larger landscapes they form a part of. We then talk about mapping these sites and how it can aid interpretations and 3D visualizations. We use known examples and attempt to show how LiDAR contextualizes finding missing sites. And then we attempt to find discrete site types using or starting to begin creating a methodology for an automated approach where we think this is where the research will head.
Kia ora tātou, Simon here, taking over from Ben. As Ben mentioned, our starting point was Nigel Prickett's The Fortifications of the New Zealand Wars, which identified over 500 archaeological sites associated with this period of New Zealand history. One thing that he recognised, and which all researchers recognise, is that there are still a number of missing sites. The locations of many sites is unknown, and we felt the LiDAR was a good opportunity to try and find some of these missing fortifications. Archaeological projects in South Auckland along the Papakura-Clevedon Road have provided a chance to re-examine some of the South Auckland borderline that was set up by the British in the 1860s during the build-up to the Waikato Wars. Archaeological investigation at the Rings Kirikiri Redoubt, led by Richard Shekels from Clough & Associates in 2013 to 2015, resulted in geophysical identification of several sections of the redoubt and outer works, with subsequent investigations locating elements of the defences and smaller structures, as well as the recovery of artefacts from rubbish dumps relating to the redoubt occupation. A bottle dump and related artefacts were recovered during the investigation led by Alan Cameron, also of Clough & Associates, near the location of the Galloway's Redoubt in Clevedon itself, along with some contemporary ammunition. Both investigations were instigated by Housing Subdivision, which continues apace in South Auckland and demonstrates how CRM research is driving archaeological practice across the country. There is, however, a significant gap in the defensive line between the Rings, Kirikiri Redoubt, and the Galloway's Redoubts, apparent in the Pricket database. This gap seems to relate to a missing redoubt known as the Upper Wairoa or Henderson's Farm Redoubt, approximately in this location. The lack of information regarding this redoubt in the literature is a little surprising. In part, it seems to relate to a comment in Leonard's 1986 volume that the site was a simple stockade built around the Henderson farmhouse around 1863 that was soon burnt down. Plowman points to an article in the Southern Cross from 1863 supporting this event. Historical data, especially from the New Zealand papers past, has meant that there is an increasing amount of new information now available, and it is clear the Upper Wairoa stockade must have been rebuilt following the fire. As a newspaper report from 1865 suggests, that the redoubt was quite significant with a capability of housing over 80 men. It also highlights the description of a use of whares, which were probably thatched raupo flat structures as the main internal barracks, as well as officers' quarters and a store. This puts it almost on par with the nearby Rings and Galloway redoubts. The records show other actions during 1864 and 1865 at the Redoubt, and the troops leaving there on July 1865 to join their regiments at Papakura before heading south to the Waikato. As mentioned earlier, the site itself has not been recorded as it is on private property. It was decided to use LiDAR data to determine whether it was possible to identify a likely location. The question of whether we were looking for one or two sites, the stockade and a redoubt, remains unsolved. The location of the Henderson Farm around 1860s is identified using land ownership records, so along with previously mentioned data, we undertook several approaches to try and find the site, including careful examination of the highest resolution DEM we could create, hill shading with PCA, and a local relief map. Despite our best efforts, we couldn't identify any definitive evidence. The DEM did illustrate that although it seemed most likely that the redoubt would have been located down Crichton's Road, where the circled area, this was because it was on a local high spot around a kilometre south of the main road. As we discussed earlier, Pricketts Catalog provided the most comprehensive database of known fortification sites from a variety of sources. The catalogue is freely available online, and where location information, either general or specific, is available, it's provided. Dense concentrations of sites south of Auckland around the Waikato and Taranaki reflect the areas of major conflicts, but there are sites all across the North Island and related establishments in the South Island. The catalogue was used to create a GIS database but around 60 of the sites do not have sufficiently accurate location information to include in the map. The Pricket Catalog does provide temporal information relating to the building of the sites, but information regarding the duration of use of most of them is not well developed. Most are recorded as being in use only during their year of construction, but the archival information shows that this was probably not the case in many situations, but reflects the difficulty of managing large quantities of historical and archival data for specific locations, particularly away from the most significant of the sites. This led to our first analysis presented here. We were able to bring data mining techniques to expand and enrich the known data from archival sources and integrate that with the spatial data from the archaeological record. We decided to use historic newspaper stories from the digital archives from the Australian Trove API. The newspaper data, which consists of millions of records, was searched for keywords, particularly redoubt, stockade, and fort, over the period of 1855 to 1880. The results were then filtered word by word to extract names of possible redoubts and stockades. These named locations were then compared with the Pricket database of places to provide likely matches, in effect giving a geographic dimension to the newspaper data. And you can see here a word cloud and the prominence of the Queen's Redoubt. The result is a combination of geotemporal control data using QGIS's new time controller, illustrating the development of the colonial and Māori bases across the country, coupled with contemporary newspaper reports of the activities at those places. The sites, blue and red symbols, are shown with flashing symbols over the top indicating the different newspaper results as they become live during the time model. Although the model and the data itself needs a lot of further processing, the potential of the approach provides an opportunity to further our understanding of the construction and duration of the New Zealand War's fortifications. For the most part, the records suggest most sites were only occupied for quite short periods, but Queen's Redoubt, demonstrably the most talked about site found in both the Australian and the New Zealand newspapers, occupies a lot of attention. The usefulness of this approach is that as archival data becomes increasingly more available, it will be possible to show that many sites were occupied over longer periods and underwent frequent changes. This includes mapping changes to the functional roles of these sites, changes in construction such as from stockades to redoubts, as in the case of the Henderson's Redoubt, and in highlighting places which have largely been ignored by the previous research, but occupied strategic positions at particular times.
Having set the scene regarding the project, we get to the main focus of the paper, which is the creation of a standardized mapping of readout sites. As we have previously argued in Jones and Bickler 2017 and 2019, potential exists for using LiDAR datasets, which are becoming increasingly available and accurate for large parts of New Zealand. And this allows for a reassessment of the quality of feature and site data available for archaeologists. Most uses of the data have been on a side-by-side basis, and our interest here is the creation of a standardized methodology to leverage LiDAR to generate local, regional, and national scale approaches to site survey and mapping. The work allowed for a standardized approach to generate multiple composite raster images for individual sites. The slide shows the method used to create the resultant LiDAR raster and images. First, we take specific sites from our ArcSite, which relate to the New Zealand Wars. Next, the LiDAR tile number was extracted to the site attribute table. If it's closer within 1 meter, the additional tile was extracted as well. Then the last tile was extracted based on the attribute table. This meant a series of last tiles existed, which showed the known sites related to New Zealand wars. Next comes the processing, where layers to multipoint and multipoint to single point generated the interpolation from NDW, inverse distance, where PCA of multiple hillshades and local relief factor was used. Maps were then generated based on these. In the future, this can be done for all sites with notable surface earthworks, and then it can be checked with standard site assessments when people check our site. And this is useful because, as you can see here, the coordinate location for the site is quite far from where the LiDAR shows it is. Briefly, this is the template we're trying to experimenting on and producing, where you've got the aerial, you've got the PCA, and then you've got the local relief, all showing different extent the microtopography of Razorback Readup. If we move to some examples and use the LiDAR template for more well-known sites, such as Rangiri, some interesting examples become apparent. So Rangiri, for those who don't know, was a Māori defensive line attacked in the Battle of Rangiri on 20 to 21st November 1863, and arguably the most important single engagement of the New Zealand Wars. Here you see the artistic impression and what it looks like from the aerial, and what pops out on the LiDAR. You notice the proximity of local hills, an overview of the river, and you start seeing other fortifications close by, such as Te Whero's Readup. If we look closer at Te Whero, it's an interesting site in itself, as it was occupied both by British and Māori. And after the 21st of November, and after the battle, a 150-man Readup was built on a group of rifle pits south of the Māori defensive line upon the Waikato River. It was first occupied by British troops, then abandoned in 1865. As you can see, in 1869, it was reoccupied by Wiremu Te Whero. So what you can see, the LiDAR shows it quite well, with an aerial to compare it against. And interestingly, the red square shows two truncated depressions, not visible in the aerials or any maps, and an interesting feature for future investigation. Because LiDAR encapsulate larger areas, as shown by the Rangiri example, you spot other sites you would not have previously recorded. One such feature type is rifle pits. For some context, a rifle pit is a depression with a cut bank, which would be a forward location for skirmish tactics. This sort of site is ideal for template matching and machine learning to find other sites. However, during the process of selecting training examples, a site to the south popped out that had not been previously recorded. Here, a series of terraces and platforms were recorded and could be a previous par. It could be related to rifle pits, and it may not be, but the point is going through the process of looking at sites either manually in preparation for sophisticated analysis, you start to spot features you would otherwise have not encountered. The contextualization of newspapers and LiDAR adds weight to the potential 3D reconstructions. As shown by the newspaper articles, the most prominent readout is Queen's Redoubt. The location of the readout was fixed by General May in 1862, and 400 men worked on the ditch and bank and accommodation huts. The site has been previously excavated, and the reconstruction was a bit liberal. However, seeing how the LiDAR captured this is key for two reasons. First, it's a good place to ground truth the point cloud, and secondly, we have a lot of information to potentially reconstruct and create a 3D model. The first problem, as you can see here, is that the initial point cloud was wrongly classified in blue. This essentially removed the parapet, altered the ditches, and removed the entranceways. By reclassifying the point cloud, you could create a better baseline visualization. The 3D reconstruction was created by combining the height data from Queen's Redoubt's LiDAR template, and with historic photos and newspaper articles and older museum models, the height data was entered into 3D modeling software Blender to show the information as a model. The sketched out rough outline of the readout was then sketched to scale using the dimensions listed in archival material. Once the dimensions were mapped out, including the base of the readout, the scale was set. Because Queen's Redoubt in Auckland is partially gone, and other contemporary readouts were used as a basis for the depth of the ditch and the height of the banks. The block layout for the buildings were then added, as you can see here, and then Jaime added the textures to the model and began to work on the look of the model itself. The model was then cut into a circular board because accurate contemporary data of the surrounding landscape at the time was not available, and it was assumed, as we can see here, it would be a better representation of Queen's Redoubt. So getting to the end, we just want to show some future directions and end on some conclusions. And hopefully we've shown that LiDAR is potentially useful for New Zealand archaeologists just as aerial photography was for the previous generation. And as Prickett's study has shown, a lot of these sites are quite significant and across New Zealand. And as development increases, it potentially threatens this removal. At least it's recorded in the LiDAR. And so what we've shown is the attempt to find a missing readout. And though we couldn't conclusively show it, hopefully we've narrowed it down so future field survey and geophysical studies can find it as well. And so we also finally argue that 3D models used on LiDAR data as quite a useful talking point to engage the public, and also more analytical to assess erosion, and it's quite key and is an iterative process combining archaeological data, historical information, and oral data sources. And that's it. Just want to say thanks for tuning in and listening today, everyone that's been involved in the project, and goodbye. Take care.